So now that we've discussed descriptive statistics, I want to put everything together. I want to include the content we talked about last week, introducing pandas and data wrangling as you get comfortable in your assignments with this. I want to bring in these concepts of data intuition. If you remember in a earlier lecture video, I had you fill out a Google form about Fermi estimation. We're going to be using those data today and those concepts in this notebook to bring in it all together, this idea of wisdom of the crowds. And by getting information from a whole bunch of people, we can often settle on the correct value. So I am going to be using the responses that you all posted to the Fermi estimation form for this lecture. So just to remind everybody who maybe doesn't remember at this point or who maybe didn't fill it out, this was the form. It had 3 quick questions. I asked you not to Google and to just answer how fast human hair grows in centimeters per year. The second question was, if every living person stood crammed together side by side, how large of an area would they occupy in kilometers squared? And the third was, how many days would it take to walk from here to New York City, assuming no stopping to fix shoes, apply sunscreen, or for sleeping, eating, or other biological needs? Okay, so we had a number of people respond to this, and those data are in the data directory in your lecture notes. So you'll see that those data are in there, and we're working out of the 0404 Fermi notebook. Okay, so as per usual, we'll get started by importing the packages we're going to use. And the first thing I'll do is read the data in, and they're stored in a file called Fermi underscore FA20 CSV. So now that's stored in the object DF, the data frame. If we take a look, here is just a snapshot of these data. And so you can see that even at this point, there are a whole bunch of different ways in which people entered how fast human hair grows in centimeters per year. There are a whole bunch of ways in which people specified the units. So some people included the units, some people didn't. And the last one is, how many days would it take to walk from here to New York City? Some people added in some notes specifying that here, when we're in the classroom, it's clear what here is. But yes, I was assuming UCSD. You can see some people put it in scientific notation. Some people included units. Some people did not. And those are the data we're going to be using here. So I want to harken back and remind you of what these tidy data rules are. So we want every observation in a row, every variable in a column, and if there's multiple tables, have some column on which you can merge. So when we are in the classroom, I asked students, are these data in the tidy format? So I'm going to give you a second to think about this. If your thought is D, you have no idea what I'm talking about, check back to earlier week's lecture videos about tidy data. If you are deciding between A and B, that's on the right track. Yes, these data are tidy, right? Each person's observation is in a row. Each of these is one person's response, and each variable is in a column. So it's applying to the tidy data principles, but there's more work to be done. There's more work to be done because even though it's in the correct format, people have answered in a whole host of different ways. So the answer here is B. They are tidy, they're in the right format, but there's more work to do before we can actually analyze those data. So when we're in the classroom, I ask students to look at these data, and I display the data and see what considerations we have to make. And we have to handle non-numeric answers, things like lots. We have to handle the fact that some people included the units in the answer and some people did not. We have to take care of unreasonably large or small numbers, think about this idea of outliers, and maybe consider whether somebody was joking in the response, right? These are survey data. We don't necessarily know that people were answering with what they actually thought the value was. And then we have to also take into account the fact that some people answered in scientific notation and some people did not. To do this, the first thing I'm going to go ahead is just change those column names. So we have hair growth, we have crammed, and we have San Diego to New York City as the column names, just to shorten these up. The next thing we want to do is check the types of the information stored in each series in each column. And we can see that they are all strings, right? Object is the type of variable name for a pandas string. And that's going to make it hard if we actually want these to be numbers. So we need to handle all these outliers, handle all the ways in which people responded and how they differ across individuals. And we need to get these to be numbers rather than strings. Because ultimately, we want to be able to calculate these descriptive statistics, things like median. If we try to do that at this point, we're going to get this long readout and let us know that there is no way to calculate hair growth, which is currently a string, and calculate the median. So we want to be able to run this line of code, so we got to do some work. So if we want to answer how fast human hair grows and clean these data up, the first thing we need to consider is all of the variable ways in which the responses here in this data set varied. So this is where we see that some people said centimeter per year with no space in between the numbers. Some people had a space. Some people abbreviated year. Some people used foot per year, different than we were anticipating. Some said 60 divided by 1 rather than just 60. And you can see that all of these need to be taken into account, as well as the fact that some people have numbers and some people have scientific notation. So there aren't that many unique responses, but it can take a lot of code to clean these up. Now, this isn't necessarily the most efficient way, but I wanted to really spell out what was going on here. So here I have a function called standardized hair. It's going to take a string in as input. And it's going to take whatever that input is, make all of it lowercase, strip out extra spaces or characters on the ends, then take care of these unique cases, right? These places where maybe somebody said 1 foot per year. I'm going to take foot per year and put it in the unit we were expecting. I am going to handle specific places where people use scientific notation in a way maybe different than others did. And I'm also going to remove commas, then take care of included unit cases. So get rid of when people said centimeter per year or abbreviated year, or just get rid of year and centimeter if it's left over and any slashes. I'm also then going to handle scientific notation. Anywhere someone said to the third, I'm going to add the 2 zeros to the second, add a single 0, so on and so forth. Strip off any white space at the end, and then convert that string to a float and return that converted string. So when I define that function, I'm then able to apply it using apply to the series of interest, to this hair growth column. I'm then going to replace the values by assigning it back into that column. Now, when we look at the unique values in that series, we see that they are in fact numbers after we've cleaned everything up. This is what then allows us to use the describe method from Pandas to take a look at our descriptive statistics. So we can see that the lowest number is 0.1. The highest number is much larger than that. But when we start to look at the average and the median, we start to get a sense that we are closer when we take the median across everybody to the actual value. So the actual value is about 15 centimeters per year. Using wisdom of the crowds, using what you all said here, the median in your data set was 16, which is pretty darn close to the actual value. Doing the same process, I'll go through it a little more quickly with the next two because the steps are the same. It's just the details that differ. If we take a look at all of the unique ways in which you all specified how large of an area individuals crammed together side by side would occupy, we've got some quadrillion numbers. We've got some strings where people said the size of California. We have people that explained their thinking, people who use scientific notation in a whole bunch of different ways, and people that included units or didn't include units. Using the same process, we create this standardized crammed function. It takes a string as input. In the code, we then take care of commas and then included units. We then take care of various scientific notation cases, of which there are many, some of which use different values for numbers in their strings, and then take care of general scientific notation. We had answers all over the board, specified lots of different ways, and then take care of unique word cases. When we do this, converting to a float at the end, define this function, same idea, apply this function to the column of interest, assign those new values back into that column, and take a look at how many unique values we have at that point. We see now they are all of a numeric type. They're all in scientific notation. If we now ask D types, for the two that we have changed at this point, they are no longer objects, they are now floats. And we can then see how you all did by looking at the median. The actual value, depending on how you calculate and how close people are standing, it's between 1,000 and 10,000 kilometers squared. You all were off by an order of magnitude of 1, which is still pretty close when we're estimating these large numbers. So you all said 100,000 kilometers as your median value, which is still, again, we're off by an order of magnitude of 1. Same idea here. When we're looking to see how many days it would take to walk from here, San Diego, to New York City, lots of different ways in which people responded. Then we can, again, standardize our responses using a function, apply that function to the column of interest stored in the column, look at the unique values, they're all numeric, and we can then see. And you have doubled the actual value, but you're still within an order of magnitude. So the actual value is about 38 days. The median of y'all's responses was about 70, which is pretty close. Okay, so why did I let you respond so freely on the survey? Right? I could have forced you to enter numeric values. One, by verifying and validating on the survey, that is one way up front to make sure your data are clean. So when you are collecting survey data, make sure you guide the user and do your best to control for what they're going to do. Now, if I had required a actual number, note that people who said 3 months when they had meant 90-ish days, I wouldn't have been able to determine that. So there are always trade-offs, but you want to make sure that your survey data are collecting the information the most accurately and in a way that's going to be easiest to analyze. Now, I didn't do that here, so I could demonstrate this for you all and start to show you how differently people can answer when you have something in mind. So look at your data, people behave unexpectedly. Be sure to get your data into a tidy format, then fix or standardize your data, or as I was mentioning, collect better data. From there, use your intuition, knowledge, information out there to consider if the values make sense. So always do all of this in your work when you're starting to wrangle and analyze data. All right, with that, take a look at these data, see how you could improve this code because it's certainly not the best code. Make sure you understand it. You will be doing something similar on a future assignment. All right, don't forget to take the Canvas quiz.